Okay, geometry fans, today's lesson is 12-3. It is symmetry. And before we start the lesson, let me tell you your joke of the day. What do you call a factory that builds good products? And the answer is a satisfactory. All right, so we're going to define symmetry and we're going to look at different types of symmetry. So the first thing is the definition of symmetry, and there are a lot of ways that you can think about it. The way that I like to explain it is the idea is an object that can map or fold onto itself. Map or fold an object onto itself. A lot of times you'll think about it as you can fold it in half. That's not always the case, but a regular polygon, okay, so this is a vocabulary word here. When you say that it's regular, when you say a polygon is regular, it doesn't mean that it looks normal. By definition, it's a polygon where all the sides and all the angles are congruent. Congruent means the same. The symbol for congruent is an equal sign with a wave over it. Okay, so there are three types of symmetry. The first one is called line symmetry. If you have a regular quadrilateral, what that means is that you have a four-sided figure, but all the sides and all the angles are the same. They're all congruent. So in other words, the name for that is a square. So by saying regular, you can assume that has to be a square because a square has four congruent sides, four equal sides, and also four equal angles. So the idea of line symmetry is you can fold the figure across a line. Fold figure across a line. So in other words, thinking about this square, and I know this is not the best looking square that I've ever drawn, but if I drew a line straight down the middle, the left side and the right side could fold onto each other. So that's one line of symmetry. I could also have a horizontal line, and I could fold the top onto the bottom. I could also have a diagonal line of symmetry where this part would fold onto this part. I could do another line of symmetry like that. Okay, so it is possible, in this case, we have four lines of symmetry. Four lines of symmetry. Now that's not always the case. If you take a rectangle and we try to draw lines of symmetry, yes, we can do a vertical line where the left folds onto right. We could do a horizontal line where the top folds onto the bottom. But you cannot do a diagonal. And the reason is, okay, I know I don't have a lot of space here, so I'll do it up here. If I try to do a diagonal line of symmetry, I'm going to run into a problem. If you try to do this, take a piece of paper, an 8.5 by 11 piece of paper, try to fold it one corner to another. It won't work because this does not fold, this part does not fold perfectly onto here. So that would not be a line of symmetry. So a rectangle only has two lines of symmetry. All right, how about triangles? A regular triangle where all three sides are congruent is called equilateral. And in that case, so each side here, I'm going to draw 3 marks. That just means that those are the same. I could have done that with the square as well. I could have put 4 marks on there. With a rectangle, I could do 1 mark for the top and bottom, and then 2 marks for left and right because they're different. They're not all the same. In a regular triangle, I could draw a line of symmetry here, and the left would fold onto the right. I could draw one from here, and this would fold onto here. I could draw it like this. So there are 3 lines of symmetry right there. Now how about isosceles triangle, which means that 2 sides are congruent, at least 2 sides, so like those and those, that and that. I could certainly divide that vertically, but it's not going to work if I try to do from either of these points here. There's no way that I can divide this in half so that it folds onto itself. So for an isosceles triangle, there's only one line of symmetry. So here's 4 examples. 1 line, 2 lines, 3 lines, 4 lines. And it's possible that there's no symmetry, that there's no line symmetry. Okay, so line symmetry is what we're most familiar with. If you take a butterfly, if you take a picture of a human being, we typically talk about that as line symmetry. Now, rotational symmetry, well, rotating means to turn. If an object has rotating symmetry, that means we can rotate a figure onto itself. Rotate a figure onto itself. In other words, everything will be in the same position. You'll end up in the same position. Okay, so there are a couple examples here. If I take an equilateral triangle, here are my 3 points. If I spin this, okay, imagine a circle here. If I spin this, and from each point to the next point is going to be the same amount, there's a total of 360 degrees. If I spin it all the way, I'll call that point A, to get from A all the way back to itself. Here's B and here's C. Now, since each of these is the same, that means that each turn, partial turn, is the same. If I divide by 3, what I get is 120 degrees for all 3 of these. From A to B is a 120 degree rotation. Now here's what happens. If I spin 120 degrees, A goes to B, B goes to C, C goes to A. What happens is I get the same look, it's the same position, it's just each letter has moved to a different place, but the points are in the same place. So I can rotate that onto itself. This has rotational symmetry, 120 degree, rotational symmetry. If we take a square, again, think of it kind of as a circle. Now there are 4 curves here. Each of those would be 90. If I rotate 90 degrees, here's point A, here's point B. If I rotate 90, A would go to B, B would end up here in C, C would go here to D. So a square has rotational symmetry. How about an isosceles triangle? Here we're going to have a problem. And the problem is that, well, if I turn this, let's say I turn this 180 degrees. After 180, this point A is going to be facing down. I'll call that A prime. Now the problem is that this is not the same look as here. It's not the same orientation or direction. So that does not have rotational symmetry. So we have line symmetry, where you can fold the object across a line. We have rotational symmetry, where the object turns onto itself. And then the last one is called point symmetry, which is a special type of rotational. And what point symmetry does is 180 degrees rotation. 180 degrees rotational symmetry. So if we take a rectangle and we decide to spin it around this point right here, if we spin it 180, then A would go to C and C would go to A. It would go halfway. Okay, imagine a circle. It would go halfway around. B would spin to D, that's 180 degrees. D would spin to B. So a rectangle has rotational symmetry. If I take an object, okay, I'm going to try to draw this here. All right, and on the other side we'll go, see, like that, like that. Here's the point that I'm going to turn around. Now again, you have to kind of imagine this. If I spin 180 degrees, this part is going to map onto here, and this will map onto here. So this would have point symmetry. Point means 180 degrees. A rectangle has point. An equilateral triangle does not, because 180 degrees, this point would be now facing down. So this would be no. If I take a pentagon, if I spin 180 degrees, this would be facing down. So that would be no. If I take a hexagon, and if I spin 180 degrees, this would, here's A, this would point, this would land on here, that would land on there, this would go to here, and this would go to here. A hexagon would be okay. So those have point symmetry. So let's go ahead and stop there. That's the end of part 1. Go ahead and pause it and go to part 2.